In this lecture, we're going to talk about testing in F# and look at various ways how to test your software and various approaches to testing. Some which are just the normal stuff that you probably already know, and some which might be new to you. But first, let's talk a little bit about testing. I have a slightly split brain syndrome when it comes to testing. I know it's useful, I know I should be doing it, but I'd rather be writing new features and code rather than tests. And if you ask what do all bugs have in common, well, they passed the test. So tests are in no way a guarantee that your code is correct. And so we can think about should I do TDD or should I do TDD? Or should I perhaps do both? Or what should I do? How can I? Because the whole point of this thing is to improve the quality of your software, to make sure that you have as few bugs as possible when you ship it to your users or customers. Now, when I say TDD or TDD, one is type-driven development, which is usually used as the acronym, but the other one is type-driven development, and they're of course complementary. But what we often find in practice is that if we use types and domain thinking and keep things localized nicely within a certain functional domain and then use types efficiently, we end up having very few bugs in the systems, and we are not testing so much, often not at all, which we probably should be doing, but well, this is how it is. We can divide testing systems into sort of three general classes that we're going to look at all three of them. One is traditional unit testing, which is essentially writing your normal tests by hand, and then you set up your test data and you run the tests and you check that everything works. Now, one of the problems with unit testing is that the tests aren't better than the test data that you give them, and we are as humans very inclined to focus on the happy path, to just see the way it should be going. You as a developer particularly is going to be blind to how your user is going to maltreat your software and feed it with absolutely ridiculous data, which will crash your system. And that is usually reflected in our tests very often. So we write tests that reflect the way we want the thing to work, and then we confirm that yes, it's working. So there's another way of doing this, which has become very popular in the functional community, and because it works really nicely with pure functions, not so much with impure functions, and that's property-based testing. Property-based testing is based around generating random, well, sort of random, because you have control over how it's generated, but basically your tests are being fed randomly generated data over and over and over again, and you get your tests run maybe 10 times, 100 times, 1,000 times, 10,000 times, and then you get a much better view of how it's performing, and you have much better chances of finding your bugs. So in sort of, you can say in general that unit testing is for code which is impure, where you are doing I/O, communicating with the world, and property testing is for your pure functions. And then there's a third class of testing, which is the UI testing, and we're going to look at that briefly, which is basically simulating what the user would be doing, clicking and using your user interface, and generating all these events and stuff that's happening, and then verifying that they are getting the result that they want. So there are a number of uses for tests, which are kind of important. In particular, when we develop, we might find that tests are actually very useful because we are constantly refactoring the code, we are changing things around, moving things around, and it's easy to break things. Now, in F# we have a very good type system, and that type system will protect us a lot of the time, in particular if we are using that type system wisely and not cheating, not just making everything object or string and int, but we are actually annotating types and forcing the usage of types throughout our system. Then every time we change the code, Visual Studio Code will go all red in all the places where we have broken things, and we need to go back and fix it. And that will prevent a lot of errors. But not all, mind you. So tests are a good complement to that. Let's have a look at these components. So, but first, what should we test? So some people are proponents of test-driven development, where basically say test everything. You should have test coverage 100%. And I have experimented with it a little bit. I'm not an expert by any means, but I found that basically you spend as much time writing tests as you writing features, and as soon as you change your code, your test will break, and you have to update the test, not because your code is correct, but your test broke, and not vice versa, which is kind of irritating to me. And in the end, when you are in a hurry, you suddenly find yourself fixing the code, but not having time to fix the tests because you're on a tight deadline, and then your tests are broken all over the place, and you know you should fix them, and all dashboards are red, and then you start ignoring them, and then what's the point of having the tests in the first place? Personal experience with this, but maybe if you have lots of discipline, no problem. I try to be selective. What should we test? And one of the things that you probably want to test is if you have some kind of reusable library that you want to distribute, you want to make a NuGet package of it, and you want to distribute it to other people, you probably want to be testing that library so that you make sure that you don't release something broken to the world. If you have software which is just internal, it's just you and your client and a few users that are getting affected by this. But if you have loads of complex business logic, which might even cost the customer money, but you have complicated logic which is easy to break because you just make a tiny little mistake and numbers don't come out right, you must absolutely test those things for sure. If you have mission critical systems, if you're doing respirators or rockets or something which might explode or stop working and kill somebody, you should be testing them a lot, and you will probably be enforced to do so by law. So then you need to know a little bit about testing. And of course, security. Here my advice is, yeah, test your security stuff, but don't write it yourself, because it's so easy to screw up security stuff. So look what other people have done and use trusted, well-tested systems. So this is my advice. Don't take my word for this. This is just my personal sort of what I'm inclined to test. So the tool stack that we're going to be using in F# is the following. The main tool is going to be Expecto, which is a very nice testing library. Easy to use and flexible. And it comes with a built-in unit testing framework, which is very similar to the NUnit framework, which is pretty much the sort of .NET standard unit testing framework. Then we're going to be using fscheck, but we're not going to use it directly. We're going to use it through Expecto because Expecto interfaces to it, and we just load Expecto and we get all the good stuff from there. fscheck is a property-based functional testing framework. And the third tool that we're going to be using is Canopy, which is a sharp, functional, nice to use wrapper around a system called Selenium, which allows you to test things in the browser. So any sort of user interface you create in the browser, you can write tests to do to test that functionality, to fill in stuff in input boxes and click on buttons and reload pages and go back and forth and all kinds of things. So we're going to have a quick look at that as well. And the third one, which I'm not going to talk about, but I just mentioned it here, is a fairly new addition, which is called Mocha, and it's essentially Expecto, but for Fable, so that you can do unit and property-based tests of your JavaScript side as well. When it comes to sort of testing the code, actually I think Canopy is quite useful in the sense that you can do some fairly simple tests with Canopy, and you will interact with the user interface, so you're testing your user interface in the same time, and you can easily catch some horrible stuff that you easily could have sort of missed. You made a change and you broke the user interface badly, and before you ship it, you'll see it. You might not catch all the corner cases unless you spend a lot of time on it, which you might not want to do. But this is sort of a nice way. But what will happen usually is that you click on things and you load things, and it will also test the server at the same time, because the user interface will be communicating with the server, and if you get the right result back, then peachy, very good. So I think actually I think Canopy is a quite nice way of testing things, and you get a lot of sort of additional server-side tests for free in a way. So property-based testing, how does it work? So it's based around the idea that we are generating random data for our tests, and very typically what we want to be doing is that we want to run our functions with randomized in a controlled way, which I will talk about, and check for invariants. So for example, if you take a list and you reverse it twice, you should get the same list back. That's a typical invariant, and so on and so on. And it takes a little while to get used to this, how to think about these things, but in the end it's quite simple, and this is very, very powerful. And then you can just say, how many random samples do I want to feed into each test, and you can get nice numbers and get better confidence in your tests. Typically, when you're using pre-generated random data generators, like if you do for a string, it will include, it will typically create strings which are maybe null, they are empty strings, they are very long strings, they contain weird characters, emojis, and what have you not inside your strings, so that you really get to test the stuff that you might not have thought about. The way these things are created is that at the heart of this whole thing is something called a generator, which is a programmable device to generate random data for various cases. But what happens, of course, is that if you run a test and it fails, and you run it 1,000 times or 10,000 times, and you get 200 failures, you will get 200 error messages. So out of 10,000 cases, 9,800 went well and 200 failed, and you get 200 error messages, and that's not really a good, like, you get overwhelmed quickly with these errors. So there's a process involved called shrinking, where as soon as it finds an error, it will start a process where it tries to sort of find the smallest possible test case where it fails, and it will report that to you. And the combination of a generator and a shrinker is called a arbitrary. It's an arbitrary class. It's an object, or it's a class which combines these two things, and it's usually these arbitrary classes that we feed into the tests to handle the data generation. I'll show you in the example how this works. So, as a bonus, what you get from this property-based testing is that you actually get benchmarking, which is really nice. So you can save the runtime data for your tests, and you can keep them over time, and then you can see how the performance of your code is varying. So you also get this nice bonus that you changed something in your code, and suddenly you see that it goes 500 times slower, and from your tests, and then you know, oops, now I need to check something. And the fact that it went 500 times slower is not something that the test is going to catch, but you get it from this regression that you have. Another thing that you can do is, of course, you can make a huge number of tests, and you can do stress testing very, very easily with the property-based testing. So you can test sort of memory usage, threads. You can run it over in parallel over multiple threads, and you can see if you suddenly have some if you are using some mutable stuff somewhere, and the threads are communicating in a bad manner and deadlocks and what have you. And of course, I put in parentheses IO because you could cheat and do some IO, but then I don't really know if that's properly sort of sane. So I've updated the safe project that I've been using and added tests to it. But in the process of doing so, I did some additional changes to it, which are sort of some I had to do and some are bonus things. So one of the things that I've done is that I have updated the fake build script to actually do deployments, so that you can make either the deployment with debug information enabled or with the optimization enabled, which we're going to use next time in order to generate Docker images and stuff like that. So that's a little addition I have. I've updated the latest Thoth fetch because I had some problems with the old one, and at the same time I updated just a few days ago. Felice Bulma version 2 was released, and I updated to that, and there were some breaking changes from the previous API, so I have updated the project to the latest Felice, and actually there was some really nice nice changes there to the better, I think. Also, interestingly, when I created the demo, I actually found a bug in the code, which I would probably not have realized otherwise. So you see, testing can be useful. So another thing that I've added just for fun is argue, which is a command line argument parser, which makes it easy to make really nice command line interfaces for your programs. I'll demo that. I have added some process management, in particular for this Canopy user interface testing, because there I have to start the web server and I have to start the client and everything and get it going. So I show how to do that in .NET, and I've updated also the server project so that I can set an environment variable content root for running it in a non-development mode. So these are the primary changes that I've done to the code. The code is available, of course, on GitHub as usual, and you can go and have a look there. Okay, so let's have a look at the demo. Right. So I've added a new project called tests to the whole solution thing, or to the project, and that project is basically standalone, but it references the server project. I can't really reference the client project since it's going to be running in JavaScript. But this one, I can use any stuff from the server code to test the server code in this project. You can look in the packet dependencies and packet references file on GitHub what I have included of new dependencies and so on for this. But let's have a quick look at what I have done. So the main code here is actually quite simple. The only thing it will do, it will check some command line arguments and see if I want to run the canopy test or if I want to run the unit and property tests. So I've separated these two because the UI testing is slightly slightly more involved and needs to probably to compile the code and needs to do things. So it takes a lot of time. So I don't want to have that every time happen every time I run my tests. So let's look at this argue, which is a command line parser. So you add it to your dependencies, open the namespace, and then what I can do is that I can just create a new type, which I call argument, which is a union type. And there I list the types of arguments I want. So I have one argument I call canopy, and that's the only one I have actually. And I've said, okay, it has some optional argument. So I can say, so the two arguments I have is I can say -- canopy browser or headless, because I can also run this browser test without having an actual browser running. And then I give it an interface with the strings of the usage, what each option should mean. I need to have a error handler. This is just boilerplate, and then we can look at the main routine. So I create the parser, say argument parser create with type argument, which I have up here. What is the name of the program? And I give it an error handler. If you don't give an error handler, it will work, but you will get really ugly exceptions. Then I say parser parse argv, which is the array of arguments on the command line, and then I can say if args contains canopy, and then I can get the result from this canopy option, and with the default value, which I say by default we run it in the browser, and then I match it with and check whether it had, if the user actually set the mode or if I should use the default value. And if I didn't want to use canopy, I'll just say run test in assembly with CLI args blah blah blah, complicated. But this is expecto. And here's the first little thing. There are various ways to run tests. You can run them explicitly, or you can just say run test in assembly. And then it will just find anything tagged with annotation test and run it for you. So you don't have to specify, which is really convenient. So that's what I pretty much always use. So let's start with looking at unit tests and see how that works. I put them in a separate module. I open expecto. I open shared because I'm going to need some stuff there. And what I want to do, most of the server code is sort of tricky to test, at least in this context, because it all takes a HTTP context and it takes this continuation and so on. So I won't be testing those functions. So the only functions that are really easy to test for me directly here are the database functions. And what I want to do when I run this, I will have an empty database. So I want to test first adding persons, and then I want to load those persons and see that I can get them out of the database and so on. And what is important, of course, is that this can run in parallel, but I can't have it load people from the database before I've added them. So I actually have to tell it to run these in sequence. And the way I do this is I define a test list, which is basically a test group. I give it a name, and I give it test cases. And every test case has a name, and then it has a function. And here I can say, okay, test case 1, add person 1, and I say, well, the result of this operation is db create person, and I create a person with some properties, and then I say expect is okay result, and then there's a string that says add okay when it runs. So here I will create run db create person, and we look at this, and you can see that it takes a person object, and it returns a result of int string. So now I check that it's okay. I could also check that it's error, but I just checked that I got an okay result back. And I add another person. I have a test case here, load people, where I say db get people. It returns a result of a list of persons, and I also just check that I just got an okay back. And then I want to load a specific person from the database, and I added reod.fel again, so I can say db get person with the name. I can expect it to be okay, and then I can look at the result and match it, of course, and get the person ID, which should be greater than 0, and the person object, and I can check that the PID is greater than 0 and that the reodor's age is 73, or else I fail. And then I say test sequence. So this is a typical unit test, very straightforward, standard thing to do. Yeah, I have added some other tests here just for examples, which are not really related to the code, where you can just test very sort of simple things and skipping tests. Sometimes you want to skip classes of tests because you're focusing in on a particular part. Also added some failures, so we can see failures and so on. But I removed them from the test. I should probably add them now in again. So there we go. So this is unit testing. Easy peasy, standard. So let's turn our attention to property-based testing. Again, I open Expecto, I open fscheck, because I'm going to need some stuff from the fscheck library as well, and then I can create the default config here, which I say take the default fscheck config and say run 1000 tests. And the first block of tests I've added here are just some really sort of simple examples. And you see again test lists, which is just a grouping of tests into this group fscheck samples. And then I say test property. So in the previous I had test case, now I have test property. And now we're going to check that addition is commutative, and I give it a function of 2 variables. And I'd say a plus b should be equal to b plus a. And now when this runs, fscheck will generate 2 integers 1000 times and check that this holds. So the same thing goes for a list. We can do this with lists. So I say give this an integer list, and then I say list reverse the list and check that it's equal to the original list. So reversing a list 2 times should always produce the same thing, and it will run that 1000 times with a list of integers. And how long that list is also going to vary. They're going to be probably 0 elements and maybe 1000 elements, I don't know. And then I have a test property with config, where actually, I don't use the config in these two. So where actually this one is going to be run 1000 times. So these are sort of the types of invariant tests that you would typically use and run. Now, one of the things that I could test in my, and this is where I found the bug actually, is that in the database code, there were 2 functions that were pure, and those I'm going to test. One was to person and from person, and these are converting from the entity framework person to the F# person, and from the F# person to the entity framework person. So the first thing I want to do is I want to create my own generator for generating person data. So, and this is how it's done. I create a class, I'll give it a member. I'll call it person here, which returns a type of arbitrary person. And then I have to generate some generators. So there's a generator for first name, and I use the gen elements function, which takes a list of things and it will randomly pick from one of those. So it's going to pick Don, Henrik, Reodor, or empty string. The same goes for the last name. And then comes an interesting one, because I said, okay, fine, now these are simple. Let's do something slightly more involved. Let's generate a alias, which is just random characters. So I say, first I say gen choose 32 to 64, so we'll pick an integer between 32 and 64. This is to match the ASCII table. And pick a character in that range. It will then generate a sample, which will be of maximum length 10 and 10 times. And then and that returns a list of stuff to me, list of integers. I will map those integers to characters. I will then create a string of the list of characters. I will take that list of characters, strings, take that string, turn it into a generator again, and then I need to make something which generates either a sum or a none for the option, because the alias is optional. For age, pick one between 100 and 101, height between 99 and 200 centimeters, and then I create a function, just helper, little helper here, create person. And then we can use this nice applicative functor style to make a generator for a person. So this is a very beautiful example of how to use applicative functors. So the complete generator for a person takes this create person function and wraps it in a generator where each of the parts of it is a gen first name, gen last name, gen alias, gen age, and so on. And then when I have the generator, I can create an arbitrary, so it will automatically add a shrinker to it. And then we have our arbitrary class. And now I can create an alternative config. So I say arbitrary should be of type personGen for this config, and max test 10, and now we can write our invariant, a proper really invariant test. And this is the one that uncovered that I had a problem with conversion between null and option in the original code. So test person properties. So what we want to do is that we want to take a F# person, turn it into a entity framework person, and then turn it back into a F# person and check that we get the same person back. So that's an invariant. So there are two things we can do. Like one is just some simple tests on the generated person. So we do test property with config, and we say expect that the first name is not null, that the last name is not null, that age is greater than 0, or we can test that age is less than 100, and we expect the height to be that should be 200. So there we go. So we just test some aspects of this generated data, and then the final test that we have is the property test for checking the invariant of the person and entity person. So here we do a db from person per x and turn it into a db person, and then we check that these should be equal. And this is the test, and that's it. So let's have a quick look, run this test. So I will do .NET run, and now expecto will run, and we see here we got loads of outputs because something failed, and oh my god, terrible stuff. And we need to look at these things in very carefully. We can see that there's something that it expected just ASCII characters, but it got the UTF character and something has failed. And of course, what has failed here is slightly not unexpected, because I had these failure tests which are designed to fail. So I'm going to comment those out and we're going to test again. So .NET run, and now it should be performed much better. And now it worked really nicely. So in the previous one it said 11 passed, 1 ignored, 5 failed, and now it says 11 passed, 1 ignored, and 0 failed. Hooray! So we can run it again. Since this is stochastic. And now look at this. Suddenly I got an error. Because age should not be larger than 100, and suddenly I had age was 100. What was it? No, probably 101. Because I had added intentionally a tiny little mistake there. And of course I told my fscheck here to just only run 10 tests, but I can easily up that to 1,000, and then we should find more failures. So we can run that again. See what happens, and we should get some failures again. But as you see, it only prints 1 because it's doing this shrinking. So there we see that age 101, and yeah, it should be less than 100. Yeah, and the previous one was 100, which is greater. Like, yeah, you get it. So this is sort of the basis of doing property-based testing. Now the final thing that we want to look at is the user interface testing. And here I've done a little bit. There's a little bit of trickery going on, so bear with me. We need to load up some stuff, and one of the things that I need to do is that I need to build the server, I need to build the client, I need to put them in a place where I can run them, start them up, and then I run my tests. So that's what this complication is. So first of all, I do some trickery to find the top level directory of this whole source tree. I know that I'm in test, which is 1 up from where the solution file is. So I get the directory where my code is, and I go 1 down, and I get the full path. Now, the build process with fake is going to create a deploy directory where everything is going to reside. So I have a deploy directory, I get the content root, which is inside the deploy directory, which is the public. And then I check where's my home directory, because if I'm on Unix or Mac, it's something, and if I'm on Windows, it's something gobbledygook here. And then I have 2 helper functions. One is build project. It creates a new process. It says it should run user bin env. This is a trick, so that I can just give it as argument fake build -t debug. So I'm going to build this as a deployment in debug mode, and it should run this from the top level directory, because otherwise fake won't work. I start the process, and then I just wait for it to exit. So this is completely sequential. Then I want to start the server, and it's the same thing. Start the process, then I set this content root variable so that the server will work. It will read the variable and set the content root or the public folder to the right place. Again, .NET run .NET server, and this time we run it inside the deploy directory. I start, I sleep for a little while, and then I return the process handle. So now this thing is going to be running. Then there's a little complication running on NixOS that you don't have to care about, and now we get to the actual test. So there's a mode which we have up here, browser or headless, and we're going to be running it in the browser first. So first of all, I set the cron dir, then I build the project, then I run the server, and this is the process handle I get from run server. So now the server is running. Then I tell Canopy to start Chrome in browser mode or in headless mode, and then we get to the actual test, which takes a test name and a function, and then there's a special syntax that we need to look at in some tiny detail. So basically all these tests are working in the following way. You give a CSS element identifier, and then you give an operator and some argument. So this first one is to say is find a element with the class title and the class is3 set on it, and this can find a lot of things, so it will return a list of matches. And then this the star equals says, in this list, see if you can find this an element with the string hello people. So if that is okay, it will continue. So the next is that it's going to find a element with an ID of first, and then it's going to set it to foo. Then it's going to find an ID with last and set it to bar, and it's going to find an ID of age, set it to 10, and height to 155. Now I've updated the view component of the server of the client project so that all the inputs for adding users have these ID tags on them, so that I can find them in the test. So this is usually the best way of doing this, that you add a prop ID and some label. And then I say click save. So now it will actually click on the button and save this user. And then it will add another user, and then it will add another user. So this is just doing the same thing over and over and over again. And I could probably have factored it out into some slightly more nice looking function and called it 3 times. Then we click save. Then I'll reload the page, and then I will get a fresh blank page. I click load, and I should get my users back and my graphs and the whole thing. And that's the test. And then I just say run. And then this goes very quickly, so you won't be able to really see what's happening. It's going to flicker around, and then it's going to just terminate the browser. So I've added a sleep for 5 seconds so that we can actually see some kind of end result. And then I tell, finally what I will do is I will tell this Canopy to quit, and I will kill the server, and I will exit. So let's have a look how this works. .NET run, and we're going to give it Canopy brow. Oh, I should probably show you the command line interface as well. .NET run -- help, and here you see the argue in action. So if you say Canopy browser, and I will run it, and now I'm going to flip to here. Now we should soon see a browser pop up, I hope. So it will first compile the project and so on, so this takes a little while. And then it will start Chrome, and it should pop up on this page here. And you should see it run through. Let's have a look. I don't dare go back because it might just... Oh, we need to go. Oh, what happened here? Okay, so I figured out I had my browser in full screen mode, so that's why everything happened correctly in the background. So let's run it once more. I hit this, and we go to the browser. And this time it's faster because I disabled the building of the project, because now it's built. So here we go. It opens up. You see how it fills in all the things. boom, and it reloads the page, and we see that there's plenty of stuff in the database now. Hooray! So there you saw it. So that was the UI-based testing, and there are tons of operators. Go and have a look at the documentation, both for Expecto and for fscheck and for Canopy. There's good stuff there when you need testing. So that was that. There's only one thing remaining really from this whole thing now, and that's adding a DevOps pipeline and some CI/CD, and that's going to be a really short lecture, and that's going to be the concluding lecture, I think, for this course, and we'll do that tomorrow, early tomorrow. I'll put that out. And then for those of you who missed the monads and functors and applicatives and monoids, it's on its way. So until later.